Okay, this is Unit 2, Lesson 10. This is our first example of using congruent supplements theorem. So we're going to start this off like we do every other proof. So given that angle 2 and angle 3 are congruent, we want to prove that angle 1 and angle 4 are congruent. So let's mark those. This and this. We want to show that. So they gave us that angle 2 and angle 3 are congruent. Again, I'm going to annotate my diagram with what I was given. And so we know this information. So what do we observe in the diagram? Well, I can see that angle 1 and angle 2, angle 3, and angle 4 are linear pairs. And I know that those are supplementary. And so notice that I'm kind of also making a plan here. So I'm kind of doing A and B together. Not everything I observe in the diagram is going to be able to be used in the proof, but oftentimes whatever we observe is something that we could be able to use depending on how we write our proof. And I know that supplementary angles sum to 180, so I know I'm going to get two equations out of there. All right, I don't see anything else really usable in this diagram. Again, we're trying to show that 1 and 4 are the same. And again, our lesson was on congruent supplements theorem, so we're going to have to use that somewhere in here, because this is an example of using that theorem in a proof. All right, so we've set up our two columns. I will post the answer document with the flow proof in it. I'm not going to go over the flow proof in this particular example. Again, I will do more of those when we talk about triangle proofs, because that is a method that you can use to help you figure out what information you need to get from the diagram, or what information you need to incorporate in your proof for your proof to be successful. But for these, the flow proof is just kind of another method of displaying the two-column proof, since these are relevant to triangle proofs, simpler proofs. These are not as complex. So we are given angle 2 is congruent to angle 3. We know that that should be our first statement. Right? If they give us information, we have to state that right off the bat so that we can use it and build from it. All right, well, I'm going to use what it is I identified or observed in the diagram for my next statement. Angle 1 and angle 2. Angle 3 and angle 4 are linear pairs, right? Definition of a linear pair. Three. Well, because they are linear pairs, we know angle 1 and angle 2, angle 3 and angle 4 are supplementary angles, which again are only two angles that sum to 180. Linear pairs form supplementary angles. Again, this is still coming from those observations, those known angle relationships, those package deal proofs that we talked about. These are statements that we're pretty much always going to make together whenever we observe these and can use them in the proof. So now we know that angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. How do we know this? Supplementary angles add to 180 degrees. Definition of supplementary angles, either one. All right, so now I have to notice that I have angle 2 and angle 3, they are the same. That was given to us. So say angle 2 and angle 3 equal 80 degrees. Well, coming from the theorem that we just talked about, angle 1 has to equal angle 4. If angle 2 and 3 are both 80, angle 1 and 4 both have to be 100 because both of them sum to 180. They are supplementary angles. So 5, we can state that angle 1 is equal to angle 4. We're congruent to angle 4. Congruent supplements theorem. Again, if you don't remember the name of the theorem, you have to state what the theorem says. If there are two angles that have a pair of angles that sum to 180 degrees to congruent angles, then they have to be equal, right? So if two angles are supplementary to the same angle, then the angles are the same or congruent.